Hello everybody, Jason KO4TFE here. Today we're going to finish up the TR-35 we've been building, and I forgot to start recording right at the beginning, so basically just to pick up, kind of catch up with where I am. We left off with just 2 steps left, and the reason was because the instructions were quite complex. It's like a page worth of instructions, but after reading them, it's actually not too difficult. Basically, we're going to put these last 2 connectors in here, and so there's 2 halves to each of these. There's a female and a male part. The male part has pins on both sides, the top and bottom, and then the female side has pins and a socket. So the male side we're going to put on the bottom circuit board here that we've been working on most recently, the one with the big heat sink, and the short pins are going to go through the hole. So basically what I've done is, like always, I put the short pins through the hole, I tacked 1 pin in place, made sure the connector was oriented the way I wanted, made sure it was flush against the board, and then we've just continued on soldering the rest of the pins here. And I did change soldering iron tips in the middle here because I had a smaller tip and it was just really having a hard time heating up some of these pads and sucking the solder down into the joint, so I wanted to make sure these were good and solid. So I just changed tips. This is a 1.2 millimeter chisel tip, or 1.6 millimeter chisel tip, excuse me. And you can see how when you heat it up properly, it just sucks that solder right down into the joint, which is what you want. That's what I was not getting before. It was kind of balling up on the surface, and we weren't really getting good flow down in. Alright, as always, let's give him a little look-see under the microscope here and see how we did. That looks good. They all look really nice there. So now we're going to do the other one. So again, same drill. We're going to put the short pins through the hole, and then I'm just going to try to tack him into place a little bit. Make sure it's good and flat, and that it's nice and lined up within the outline on the board there. That looks good. So I'm going to do a diagonally opposed hole here to just kind of hold them in there. I could touch up our tacked one here. Alright, and now we're just going to plod along and finish all these connections here. Let's check on him. Alright, looking good. So now what we're going to do is we're going to take the top half of the board. We're going to lay it upside down on our desk with the two empty slots for our connectors closest to us. And then we're going to install the female connectors. Now we want to take our bottom board, flip it over, and plug it in. You want to make sure everything's lined up, that you've got all the rows of pins aligned properly, and we push our board stack together. And there will be a gap where these don't completely mate. We're going to take care of that in a minute. So now I'm going to go back to my safekeeping spot here where I had our board screws, and we're going to screw these two halves together. Just loosely inserting these for now until they're all four in and the boards are aligned properly. When you're connecting these two board halves together, as you're pushing them down, if anything feels off, if it feels like there's any interference or that the pins aren't mating properly, just back off and realign them and install them again. You don't want to break anything in the process of putting these together. Alright, so those are together. So now what we're going to do, before we solder these upper pins, we want the connectors here to mate as tightly as possible. So what we're going to do, I'm actually going to get a flathead screwdriver here. If you had a plastic, credit card or something like that, might also work, or a spudger where you can take apart electronics. But I'm just going to do this carefully. We don't want to scratch the board or anything, but we want to push this top connector down so that there's no gap between the joint of the top and bottom. And so what that's going to do is that's going to leave you a gap at the top edge of the board here where you'll see the brass pins. But that gives us a whole lot of mating surface here, really good contact between the two joints. So now that that's done and everything's aligned properly, we're just going to go solder these guys. Feed a bunch of solder over this guy just to give me a little more room here. I do really like this tool though. I think it gives me a lot more control over the solder than trying to just hold the loose end. Alright, As always, let's see how we did. Not that good on that one. Yeah, some of these guys are going to need some touch-up, which I can kind of see with my naked eye too, so it's not too surprising. Just got one more to touch up here. This fourth pin over is being cantankerous. There we go. Alright, so I think that is all of the assembly steps, or soldering steps. So I'm going to go ahead and turn off this guy. So the only thing left before we start the adjustment process and calibration is to put in our microcontroller. So he comes in a little sleeve to protect the pins. So take off your rubber band and he'll slide out. And then we want to let me get this again so you can see. We've kind of talked about this before, but the socket will actually have, you can see right there in the middle, there's a notch right there above the 28, and that is for pin 1. That should be facing towards the center of the board. And if we look at our microcontroller, see if I can get a better angle on that. It's kind of hard to see. Kind of see it there, but there's a half of a circle there as well, that notch. So that notch should line up with the notch on our socket. And I don't know if he's formed these leads or not, so what I'm going to do is just set it in here and see how it looks. Yeah, it looks good, but you want to check and make sure, because by default these pins are kind of flayed outward, and that'll prevent you from sticking it in the socket, and you can actually bend them and damage the microcontroller. So if they are bent out of shape a little bit, what I like to do is just kind of rest it on the bench so that the whole row is flat, and you can just rock it a little bit to flatten them out. But you don't want to use pliers or anything. If you just make sure they're all in line, you can put them on a flat surface. But it looks like they're pretty well formed, so you just gently, a little bit at a time, rock them into place, make sure it's seated all the way, and there we are. So now it's time to go ahead and start going through the alignment process. Alright, so I've gathered some tools that we're going to need here. So I have a digital voltmeter, a watt meter. This is something I picked up at Hamvention. Actually, I was looking for watt meter from MFJ, and of course the first time I picked to go to Hamvention is right after MFJ announces that they're closing up shop and they're not going to be there. But Gigaparts has a new line of products called Intellitron, and from what it looks like to me, it's the same vendor that MFJ was getting some of this stuff from. So I just picked up a cross needle meter. So we'll need this in a minute. I'm going to set it off to the side a little bit. There's another little trinket I picked up from Hamvention. I went by ABR's booth and got this PL259 to BNC adapter. Unfortunately, this was the only one they had. They sold out of everything really quickly. Of course, I was only there Saturday, so I imagine Friday they probably had more, but this was the only jumper they had left, so I picked that up. We also need a dummy load. This is the QRP Labs dummy load, and I don't know if any of you have this, but if you don't have a watt meter, you can actually use this to measure the power output. There's a probe on the board you can measure and do some calculations and figure out. So there's another option. And then we need a power source. Unfortunately, I think we're going to need an adjustable power source, which I don't have, so I'm going to figure out. I'm going to have to figure out something, but there's that and just some clip leads. So the first thing we want to do is ensure that there are no shorts on this board on the power rails. So let me get everything, let's see, oriented like the picture on the document here, and I'll show you in a minute. Oops, where's our ohms? There we go. So digital voltmeter or digital multimeter, if you're not familiar, we're in the ohms setting here. This one is auto ranging, so it will automatically detect what range I'm trying to measure. According to the document, between all of the power rails and ground, we should have more than 1,000 ohms between those two to make sure there's no shorts. So if you have a meter that you have to manually set the range, you'll just want to get it in the kilo ohms range. And I'll show you the picture here. So the points we want to test, so here's our screen with the 4 pins on top, and we've got our 4 pins on top here. Here's our tuning encoder, and here's our tuning encoder. So I think we've got the orientation correct. So these 2 pins are going to be our 12 volt rail, and then here we have our 3.3 volt rail, and this is the 6 volt rail. So we'll want to measure all of those between those and ground to make sure that there's no shorts. So let's see if we can probe. I want to make sure to just touch these and see, we got 0.2 ohms. So good, the meter's working. So let's go between. So let's see here, we'll just measure and see what we get. So I've got infinite, oops, so I've got infinite resistance there. This one, also, well, there must be a capacitor on this line, so we're at 60 kilo ohms. Let this settle out. Make sure it doesn't drop down too low. All right, 14.6K, so I think we're good there. So let's see, let's count our pins over here. 1, 2, 3, 4, 5. The 5th pin over. 1, 2, 3, 4, 5. We got about 5.5K there. And then our 6 volt rail is the 2nd pin over from the top on this row. So let's measure that. Oops. All right, so I think we're good there. I'll set this aside for the moment. So one thing too I forgot to mention, I did not film the next steps after we finished doing our soldering, but I did clean up the boards a little bit to get the rosin off. I just used some isopropyl alcohol. Actually, I ended up getting some denatured alcohol as well for a camp stove I have, so I used that. And a toothbrush just to very gently scrub the bottom of these boards to get that off. You don't want to be rough at all. You don't want to damage any of the pads. These don't have any surface mount components on the bottom, so it's not terribly critical, but if you did, then you'd want to be really, really careful. Make sure you didn't knock any of those off because they are delicate. So I just cleaned these up a little bit with isopropyl. Once you do that, or actually denatured as well, once you do that, it'll evaporate and sometimes leave some white chalky residue behind. So then I just scrubbed it all with water, rinsed it with just clean fresh water. Distilled is ideal. And then let it dry. It's been drying for about a week or so. And then I also went ahead, if you remember, we didn't add our nail polish to the nuts, so you can't see it because it's between the two boards. Well, maybe you can. I have some nice fancy orange nail polish there. I didn't have clear. So I just put some nail polish on the nuts, and then also on the nut holding the heatsink on in between there, just to finish up the final pieces of assembly there. So now what we need to do is check the receiver. Alright, so let's connect our antenna here. We have our audio on this side. I hope this is a standard power connection. I think it probably is. Power pole adapter here. Yeah, good. Battery is off for the moment. So we need to make a couple adjustments here. We want to turn the TX power pot fully counterclockwise, so that's this one. So it's, let's see, it's all the way down. The RF gain, we want fully clockwise. And the volume control about 1/4 of the way up. Okay, I had a little mini heart attack there because I wasn't getting any audio, or it wasn't powering up. So the instructions say you should turn on the power switch, which I skipped. I forgot that this has a physical power switch. So let's turn that on, and hey, look at there. We have actually got some some activity. That makes me feel a little better. Okay, so the frequency should change as the encoder is turned, which it does. That's good. And you should hear signals, or at least some band noise. Hey, there's some noise. Okay, so now let's take our band switch. There's 30, there's 20, there's 17. Alright, so that works. So now let's check our RIT. The RIT is shown here, and the indicator comes on. Turn it off. So the volume I know works. I'll check that. See if we can actually find anybody on the air here. Okay, so now let's see if our RF gain, when he comes back, see if we can yep. Alright, so let's turn this off for a second. So our next step is to disconnect our antenna and connect a 50 ohm dummy load and our watt meter. Alright, so we've got that on again. Let's turn our radio back on. And obviously we should have no signal because there is no, it's just a dummy load. So let's get a little flat bladed screwdriver here. Alright, so let's adjust our signal LED, which is the one right under the top here. So we want a faint glow. I don't know what faint glow is. Maybe like that. So I can just barely see that. I don't know if it even shows up on camera, but I can just barely see it glowing. Let me turn off some of these lights I have on here, just so I can better. The tweak is very, very, or that trim pod is very, very sensitive. You tweak it really easily. Alright, so I've got just a faint glow there. Okay, so now we're going to adjust our, I think it's quiet when I touch it. We need to adjust our final amplifier FET bias, which is R40 on the lower board. Let's see, does he have these labeled with, yeah, PA bias is this one right here. Measuring current, if you're not familiar, you have to, when you measure voltage, you're measuring voltage across something, right? So you just attach your leads across what you're trying to measure. When you want to measure current, you have to actually measure current flowing through, so your meter has to be placed in line with what you're trying to measure. And most meters, like this one, have an amps connection, a voltage connection, and then a common. So you leave the common where it is, and let's put the amp connection here. So what I'm going to try to do, let's see if I can connect the ground here, all these power poles. And then I'm going to connect the positive there, and then the negative is going to go in here. And let's turn this to our DC amps reading. Oh, actually I connected to I said I was going to do this, and really it doesn't matter. You'll just get a negative reading instead of positive, but just to make it easier. Alright, so we're measuring about 80 microamps right now. So rotate the RF power control and volume fully counterclockwise. So our TX power is this guy, the second knob. And our volume is the one on the end. Okay, so now we're going to adjust our R40 fully counterclockwise as viewed from the back of the board, which is going to be this way. I think we got him there. Set the band to 40 meters. Observe the current drain in receive mode. It should be less than 100 milliamps. Close the key and the current should increase by about 10 milliamps, which it did. Went from 74 to 85. You want to set the bias until the supply current just starts to increase. Set the control for an additional 4 or 5 milliamps above what was previously noted. So with the key closed, we're at 85, so I want to get up to about 90. I'm not sure I've got enough hands for this. Let's see. I need to change this tip. It's just not fitting well. Ideally, you would have a nylon or a non-conductive screwdriver for this, but I don't happen to have one, so. Oh, that's too much, I think. Let's go back a little bit. And he notes not to go beyond this, or you'll just increase the power draw and reduce the efficiency of the system. So there's 90. So we were at 85. Now we're at 90. All right. So I think that's pretty good. So now we're going to disconnect our meter, our current meter. And we're just going to connect the battery. Alright, so we've got our power meter. Our radio's connected directly. Let's turn this guy back on. So the side tone should just be audible as you advance the volume control. Alright, so that's working. So now we want to adjust the transmit pot, which is this one. Turn that down. So when it's all the way up, we should see about 5 watts. This is exactly where we are. Great. Not sure why I keep having audio dropouts. I'm really hoping that's my speaker. Alright. Okay, so now our side tone needs to be adjusted. Alright, so the side tone volume, it says, will change as the transmit power is set. So with low power, we've got, it's a little too quiet. As we turn the power up, that's pretty good for that. So I'm going to try to get it in the middle. Actually, I think I'm going to err on the side of high power because that's probably where I'm going to be running most of the time. Alright, so now we need to set our battery warning voltage, which is this pot here. And so if we set this all the way clockwise, that's the lowest level. I noticed that when I was transmitting, my battery voltage was dropping. And it was blinking. So yeah, you can see it blinking there in the lower right hand corner. And I've got, I think this, let's see if I can measure this. You can adjust it between about 9.5 and 11 volts. Now, this battery is a 12 volt battery. Let me get my clip lead back. I want to clip this guy to a good ground somewhere. But when I transmit, it does, unfortunately, dip down a little bit. Alright, so I need to measure the output of this radio here. Switch my leads back over to the voltage measurement. And we're 11.48. So right now when I transmit, we're going down to about 9.9. That is not great on this this little battery pack, because it's still showing 4 volts, or excuse me, 4 bars. I may need to get a little bioenno or something. But let's see where we're set now. So fully clockwise goes down to about 9.5 volts, he says. So let's see if I can measure here. So we're at 9.9 and we're not blinking. So let's turn this up just a little bit. Ideally, you'd want an adjustable voltage supply that you could just measure this by adjusting the output voltage. I don't really have that, unfortunately, so I'm just making do here. So there we go. Our voltage measured here is basically, should be right around 10 volts. Okay, so now we're going to adjust the filter. So what we're going to do, set the receiver to 40 meters, narrow mode, which actually I don't even know how to set it to narrow mode. How do I do that? So like this. There we go. Set the transmitter power about midway. That's going to be, I think, let's see, so there's half, goes all the way, so we want to be about there. All right, so I'm going to key this. We want to turn this till we peak that sound, how loud the side tone is there. If you had an oscilloscope where you could look at this on a meter or on the screen, you could definitely get it more precisely. For now, I think it's pretty good. So there we are. So now I think we can turn everything off and actually just go ahead and put the case back on, put the case on. We'll make sure that we put our screws back in here. Then we're going to put this in. We're going to put this in the bottom half of the case. Slide our BNC connector over. Okay. Now one thing I did, I took off this spacer for the VFO because it kept falling off, so I want to put this back on before we put the top of the case on. So there's that. Now we're going to slide our case on, and then we're going to use our four long black screws here to screw this guy down. Get the right tip for this. There it is. You know what? I forgot one crucial step. It's the most important step and the most fun step. just to pull the film off of this screen before I put this on. Alright, let's grab our little tab and we'll just slowly pull this off and enjoy. Oh, so satisfying. Alright. Now we'll slide him back on. Before I tighten these down, I probably should get all 4 of them started too, just to make sure. We did all of our alignment checks and stuff, what seems like an eternity ago. We started this project, but just to make sure everything still lines up, tightens up with no fuss. Alright, so now we're going to put our 3 nuts on our toggle switches here. Alright, so let's go ahead and get our fancy switch caps on here. Actually, you know, before I do that, I'm going to tighten these nuts just a little bit. And like before, we're going to try to not touch the case at all, or not touch this label, because we don't want to scratch that up. But I do just want to snug these in just a little bit so they don't come off. Alright, so our red, although this looks more orange to me, but our red cap goes on our power. Our 2 white ones go on these guys. Okay, so now we want to place these on. So the red one goes for the low battery. And he specifically mentions be careful because it's easy to damage these putting them in. So I have no idea if you'll be able to see this, but there's a flared spot at the bottom with a little notch. Let's see. I'll get this close enough here. Wrong way. So there's a little flared out spot at the bottom that keeps it from popping back out of the case, and there's a little notch in that that allows you to compress it a little bit as you put it in. So you just want to gently kind of compress it and then put a little bit of pressure. There we go. So the red one goes there. The orange goes for our RIT. So we're going to do the same thing. So I'm basically pushing in. Oops, yeah, I don't want to break that. Pushing in a little bit to try to compress the base as I put it in. Flush, and now we're going to do our last one. There we go. Now it's time for our knobs. And one step he says to do, I might have trouble with. I don't know if I have a 1/4-inch screwdriver, which is what he says we should use to, we should deburr our knobs. Let's back out our set screw here. I don't know if this is strictly necessary. So back out the set screws and rotate a 1/4-inch drill bit to remove any burrs and replace them. Let's just kind of spin him in there, I guess is what we're trying to do, to get rid of any plastic burrs. And then we will put our set screw back in. And then we're going to put him on this knob so that the set screw faces the flat spot in the knob. But on this one, remember that we need enough room to push it down as well, to click it. So we tighten him up. I think that might be okay. Give ourselves a little bit more of a, so there's that. All right, I think that worked. I know what's going to happen is I'm going to lose one of these set screws trying to deburr these holes. So I think I might actually just skip this step, just because I know myself. Let's see, rotate him all the way to the left, and I'm going to try to line up my notch there. With the marking on the case, so that everything is all right. Everything lines up correctly. So turn that down. Back this guy out a little bit. Make sure, yeah. So these are still floating a little bit above the surface, which is what you want, because you don't want to scratch your label up. Okay, pro tip, put the tuner or the VFO on last, because it makes it a little bit difficult to get to these guys. I think what I can do is if I turn the volume all the way up, I can get around him this way. Back this out a little bit. That one's a little too close to the panel. I can feel it rubbing, which I do not like. There we go. That feels better. Nice. And I did not put on the front acrylic cover for the screen. So I hope, yeah, it looks like these are self-tapping screws. So I'd hate to have to take this all the way back apart. peel back our plastic here. Peel back our plastic here, trying not to touch the surface that's going to be facing downward. And let's get us a little, probably a number 1 Phillips. Yep. I'm just going to get this guy started. Now let's do this one. And there we go, guys. It's all done, ready to get on the air. So I hope to be able to work a whole bunch of you on this radio. I look forward to taking it out in the field and doing some activations. And I'm excited. Yeah, this is definitely the most expensive kit I've ever built, and the highest quality for sure. Like I said, just overall been super impressed with this. It looks great. I love all the controls. So yeah, we'll see how it works when we get it on the air. Till then, 73.